Hello everyone, welcome back again to my YouTube channel. Today it is a turn to compute distance to road and distance to river to calculate landslide susceptibility mapping of my study area. Before we go to the practical aspect, I would like to remind you to subscribe my YouTube channel and hit the bell to gain updates and notification. If you have any suggestion, question related to landslide susceptibility and other issues, please don't hesitate to put your own comment on comment section. Let's get started. As I have acquainted, today we will give special emphasis how to generate raster data from road and from river. Distance to road and distance to river have its own significant contribution for the occurrence of landslide susceptibility in a certain area. So we need to have river data and road data. If you are interested to download both road and river data, you can use ETOMAP server, and I will put different data hub links in the description box. Let's get started. This is the ETO road data, and this is the ETO river data. Both road and river data is available, and there is my study area here. First step that we are going to do is we need to clip out on the basis of my area of interest. So this is my study area, and both river and road data is available. So the first step is we need to clip out from the larger data set. To do that, let's go to view, or you can go to analysis. From view, there is geoprocessing tool. Click geoprocessing wizard is appear in the right corner of your machine. So there are two possible alternatives to find your tool. The first parameter or the first alternative is you can write on find tools like clip and make it enter. It directly lists the clip. The second parameter is, or the second method to have a clip is go to toolbox. From toolbox there is analysis tool. From analysis there is extraction toolset. Double click and select clip. So clip is helpful for clipping the vector data, whereas extract by MSK is used to extract or clip out the raster data. Since our data set is linear or vector data, we use a clip function. Then the input data set is one of the vector data. Let me take your road. The clip feature is the area of interest. Then select Warada boundary. Finally, we need to rename our output file name. Let me leave a default, but you must know your working directory where your final output is set, because we use at the end of this session to make weighted overlay for calculating landslide susceptibility mapping. So run. Automatically we come up with a result of road within this administrative boundary. Let me click on the river. So double click, and input feature or data set is your river. The click feature is my study area or area of interest of the administrative boundary. You can rename your output name as river click, save and run. Finally, we come up with two datasets of river and road, and the larger dataset is not crucial for us now. Let me remove, right click and remove those datasets. Here we do have two datasets. The one is the river dataset. The second one is a road dataset. So let me use road for analyzing distance to road. The main interpretation for this is area with nearer to the road is highly susceptible for landslide, because Within the construction of road, different topographic aspects or topographic structures will be destabilized, and it is highly susceptible for landslide. So on the basis of this, we would like to create a raster data from this using technique. Then let's get back to our Excel data. Here there is distance to river and distance to road. The threshold is similar, and interpretation is area with less than this linear object is very high susceptible to the rivers. Area far to the species if a certain topographic area or geographic feature is greater than 1000 meter, this is low susceptible. So on the basis of this, we will generate buffer. Let's get back again and back. Buffer is found within analysis tool. Here there is proximity. From proximity, the different buffer type is available. Buffer create the Siam polygon. There is generate near table, graphic buffer, multiple ring buffer. I need to use multiple ring buffer since I am very much interested within a certain fixed distance. The impact of land susceptibility, the impact of road to land susceptibility. So click multiple ring buffer. We need to fill the parameters that is listed here. As far as the input feature is concerned, we need to use the linear object, either a river or road. In this case, let me use road. The output feature class is multiple ring buffer. You can put your own name in your working directory. The third significant point is distance. Distance is the threshold that we have seen earlier in our Excel sheet. So the thresholds are 100, 200, 500, 1000, and greater than 1000. So let's get back to my ArcGIS Pro. The first distance is area less than 100 meter. Let me add the second buffer, 400 meter. The third buffer distance is 500 meter. This 500. Fourth one is 1000. And final one is you can make it larger, for instance, 4000. Since I have the numeric value here, I need to set the unit of measurement. So the distance unit is meter. This is assigned in my Excel sheet. So meter is unit of measurement. Leave it the other by default and hit run to execute this buffer. Then run. Finally, the result is appeared in this format. Then let me uncheck the rest of the attributes. The rest of the dataset. This is the buffer. Since the dataset is more larger than my study area, I need to clip out on the base of my area of interest. To perform that, let's get back again to geoprocessing tool and go to clip. Let me select clip. The input feature or the input dataset is the multi-ring buffer that we have created. The clip feature is our study area, the boundary. You can give your own name, then hit run. Automatically, we generate the buffer of road. Uncheck the larger dataset. This is a buffer map of my study area. So I need to convert this vector data to raster because all the data sets are in the format of raster. Then let me get back again to convert this vector data to raster. You get back to your processing and select conversion. From conversion, let me scroll down to from raster to vector, or I mean from to raster. From the available option, I would like to select polygon to raster. Since my dataset is vector polygon, I would like to convert to raster. The input parameter is the clipped dataset, this one. The values object, and let me rename this file output as distance to road, d road. The cell alignment type is cell type, and the cell size should be fixed here. Since my working spatial resolution is 20 meters, this 70 should be converted to 20. And finally hit run, and we come up with buffer raster dataset. We will have a look how to visualize this raster dataset in better way for the sake of visualization. Here there are 5 classes. Let me uncheck the rest to have a look. This is the buffer map. Let me take good visualization. Right click, go to symbology. From symbology, I would like to convert the color scheme. This is the map. So I need to reclassify again to 5. 1 means there is highly susceptible because it is nearer to the linear feature of a road. And let me reclassify and let me provide a final data. Get back to geoprocessing and collapse the conversion tool and scroll down to spatial analysis tool. From spatial analysis tool, there is reclass. From reclass, select reclassify. Input dataset is the buffer or the distance to road raster map, and the value is value, and click on classify. From classify, I need to reclassify into 5. Since I have 5 classes, I would like to reverse the value because one indicated that there is high susceptibility because area is nearer to the linear feature of road and river. So the value should be 5, and the 5 means in this case far from the linear object. That means area greater than 1000 meter. So I need to reverse this. So the value is reversed, and hit run, and finally we come up with the final drainage density and distance to road and distance to river map. A river map should be computed in similar fashion, and let me have a look in better visualization. Go to symbology. From symbology, let me select the color and let's interpret in a smart way. Okay, based on the available map here, this is a map of distance to road. This red color indicates that the area is very high susceptible for landslide, and the next color means area between 100 and 200, with the color of the orange is highly susceptible. This is moderately susceptible. The rest are low and very low susceptible.